So translation will talk about all the forces, and rotation will talk about all the torques, right? So first we have to find out all the forces, right? So this weight, this is given. Then we have this string, so we have this tension, and then we have this string, so we have another tension. Right, guys? So we have three forces, T1, T2, and W. Do we have any other forces?
Gravitational force.
So that is the weight, right? Weight is the
Yes, sir.
gravitational force, right? So all the forces are there. Now we have to write the translation equilibrium. But before we do that, this is 37 degree. So if I draw two parallel lines, right? One is in this way, the other one is in this. So this one and this one is parallel. This is 37. So this would be how much? This would be how much?
37.
37. Similarly, this is 53, right, guys? Right.
Yes, sir.
Okay. So we have this vertical part, and then we have this. So we have two parts, right? One is this vertical part, and then this horizontal part of this tension. And then we have this vertical part and this horizontal part for this tension. Okay. So what would be this? For this tension, what would be this part? This is with the angle. With the angle part, what is that part? Yes,
Cos
everyone.
theta.
Yeah, but what cos theta? This magnitude is T1, right? So
Yes, sir. T1 cos theta.
T1 cos 37. Yes, is that correct, everyone? Rishita and Amna, is this correct? Yes.
Yes, sir.
Similarly, this would be how much? This one.
T1 sin theta.
So T1 sine 37. Right. Good, everyone. Similarly, this is T2 cos of 53, and this is T2 sine of 50. Right. So now we have written all the forces. And now we want to calculate the translation. So let us write the translation. So first would be the horizontal equilibrium. So whatever force is acting in the right direction, that is balanced by the left one. So what is that? Horizontal.
Sir, please can you repeat again?
So I'm saying that this is the translation equilibrium, right? So
Yes,
at
sir.
this point, let's say these are the forces. So this force, vertical force, is balancing the vertical force. And then this right force will balance the left force. That is why this is at equilibrium, right? So
Yes, sir.
this is the horizontal one, this is the vertical one. So writing the horizontal one, what is the left force, what is the right force?
T1 sin 37
Yeah, so this is the left one, absolutely right, good. And this is equal to T2 sine 50.
sin 53.
Correct, everyone? So this is the horizontal force. Now let us write the vertical force. So vertical one would be how much, guys? What is the total upward and what is the total downward?
T1 cos 37 plus T2 cos 53.
Yes, so this is the upward and downward is
Is equal to W.
yes. So this is the translation equilibrium, right, guys? And before we do the calculation, let us recall that what is this 37 degree. So this 37 degree we are familiar, right? So if
3, 4,
this is,
5.
yeah, so this is 3 and 4 and 5, right, guys? Oh, so this one is this one is 4, this is right. Do you guys remember this one?
Yes, sir.
So
Yes, sir.
cos, yeah, so this is 50. So if I write cos 37, that is B by H. Then I write sine 37. So this is 5, right? So sine 37 is P by H. Similarly, cos of 53. So that is B by H. And then sine of 53 is perpendicular by H. So these are the values that we have. Okay. Now let us get back to uh, the rotational equilibrium. So for rotation, we require what? For rotation, we require axis of rotation, right, guys?
Yes, sir.
So where we should choose the axis of rotation so that the calculation is simplified. Which axis of rotation we can choose? So we have three axes. One is this one, the other one is this one, the third one is this one. So which axis of rotation you guys want to choose? Which one? Yes,
Sir, is 2 better?
yes,
Is
is
second axis better
is
to
two
choose?
better. Yeah. So whatever we want to choose. So all these we have how many torques, right? So we have if I choose this one, then I have this first and two. So two torques. If I choose two, then I have this one and two torques. And if I choose this one, so again I have these two torques. So in all the cases, I'm getting two torques, right? So
Yes, sir.
I can choose any one. So what is your preferred one, guys? Which one you guys want to choose? Second one. Okay, so Akib is saying second, so let us choose the second one, right? So this is the axis of rotation. So whenever we are taking the axis of rotation, then we don't count the torque on this axis of rotation. We don't count the force on this axis of rotation, right? Right, guys?
Yes, sir.
And this T2 sine and T1 sine will not provide any torque, rotational effect. So only this one will provide rotation and this one will provide rotation. Correct?
Yes, sir.
Okay, so this length is D, total length is 2. So what would be this length?
2 minus D?
Minus D. Absolutely correct. Good. So now we have distance, which is the perpendicular distance. So this is the axis of rotation and this is the force. This is the axis of rotation, this is the perpendicular distance, and this is the force, right? So we know that from rotational equilibrium, tau 1 plus tau 2 would be 0. Right, guys?
Yes, sir.
So what is tau 1? Let us torque at this one. So what is that?
T1 cos 37.
Cos 37, that is force. And we also have to write the distance, right? Torque is perpendicular distance and force. So force we have to, what is the perpendicular distance? Yes. What is the distance? So this is the, as you said, T1 cos of 37, and this is the perpendicular distance, right?
Sir, can it be T1 sine 37?
No, 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 no. So this is along the, so this is perpendicular to the axis of rotation. So this will not create the rotation, right? So let's say this is your thing and this is your axis of rotation. So only torque will be provided by this. This will not provide torque. This will not provide the rotation effect, right? This force
Yes,
will
sir.
provide the rotation effect. This force will provide the rotation effect. This force, so only the parallel force will provide the rotational effect, right? So
Yes, sir.
this one will not provide. Only this one. And this one is T1 cos 37. So as you say, T1 cos 37. And what is the distance? D, right? So I should write it as, so let me write as R and F plus R and F. That would be the torque. But for the case of this one, torque would be positive or negative for this one.
Negative.
Negative, right? So using the right hand rule, so that would be good. Good. So that is minus. And for the case of this one, what would be the sign?
Plus.
Plus, right? Good. So now let us write the distance, so minus of t, and f1 is t1 cos 37. Plus, what is this perpendicular distance? 2 minus d, and t1 cos of 53. So this is 0. Is this clear, everyone?
Yes, sir.
So we can write
Yes.
2 minus d t1. Oh, this is t2, right? So 2 minus d t2 cos 53 degree, and this is d t1 cos of 37. So the question is that we have find out d. This is the question. So now let us use this equation, right? So let us use this equation, and we already know that what is sine 37. So T1 sine 37 is 3 by 5. T2 sine 53 is 4 by 5. So 5 cancel, and we will get T1 equals to 4 by 3. So this is the result that we will get. And we will not require this one, right? So we will not require this one. So let us use this for relation. So T2 we know, T1 with, right? So 2 minus D, T2, let us keep it this way, cos 53 is 3 by 5. And T1 is 4 by 3, right? T2. And cos 37 is 4 by 5. So this 5 will cancel, T2 will cancel. So we have 2 minus T, and this is 3 3s are 9. And then we have this 4 4s are 16T. So how much is this? So this is 18 minus 9D is 16. So this is 18 equal to 25D. So D is 18 by 25 meters, right? So if I want to change it in centimeter, so this is 100 centimeter. So 25 fours are, so this is 72 centimeter. This is the distance. Is this clear, everyone?
Yes, sir.
Yes, this was a very important question. That's why, yeah, I created this problem. So if you guys have some doubts in this question, please let me know. Right? We only use this translation and rotation. So you guys please note it down and then we'll start the gravitation chapter. Whenever you want me to scroll down, please. So let me draw this diagram in here so that it is clear. Okay, right. So we have this one, and this is the axis of rotation, and we have this force, which is T1 cos of 37, and we have this force, which is T2 cos of 53. So this is rotating in this way, this is rotating in this way. And this is D, and this is 2 minus D. Oh, Ilham is joining now. Yes, hello Ilham, Assalamu alaikum. So we are doing just that problem that we couldn't do in the previous class. So you just note it down, right? You just note it down. We just applied the translation and rotation. Yes.
Yes, sorry, I got late. I actually forgot because I had parent-teacher meeting, so I just came back.
Yeah. No worries, no worries. So don't worry about those trivial things, right? So we didn't start the new chapter. We are just doing this previous
Okay,
question. Yeah.
okay.
So in yesterday's class, my laptop switched off and then I got disconnected. And, yeah. So thank you guys. You were waiting, so I just texted the Learnivio team to tell you guys that. Get the class. Quickly note it down, everyone. And if you have any doubts in this question, please. Main crux of this chapter is that we will write all the rotational analog of the motion, right? And we will have, so earlier we had this F net was 0. So this was translational equilibrium. Now we have rotational equilibrium, which is tau net is 0. So these are the things where that we have. And lastly, the angular momentum is I omega for fixed axis. Whenever you guys have noted it down, please yeah, whenever you guys want me to scroll down, please Yes, noted, guys.
Yes, sir. Finish.
Yes, sir.
Now,
Yes, sir.
these are the terms. So this part also completed. Yes, noted, everyone.
Yes, sir.
Yes, sir.
Yes, sir.
Now let us start this new chapter, which is gravitation. Newton's law of gravitation. So today, what we will study? Today, I want to complete up to. So first, we will do the. First, we will cover this Newton's law of gravitation. And then we will understand about the superposition principle. And then we will talk about the Kepler's laws. Right, so Kepler has given three laws, and Newton used that idea to prove this law of gravitation. This law was very important, right? So Kepler's law first was this law of orbits. So usually people thought that, or mainly Copernicus thought that the planets revolve around the sun in a circular orbit. So, but Kepler's, yeah, so gave the new idea. So this is law of orbit. Then there was this law of areas, and then the third one is law of period. So we'll talk about this, and then in the last we'll talk about the acceleration due to gravity. And earlier we used to take that this gravity is fixed. But now we will understand that what is the gravity at surface, what is the gravity above the surface, and what is the gravity below the surface. So all these things we will try to understand. Let us hope that we complete these four questions today. So that question took our time, right? Okay. Quickly, let us quickly do this Newton's law of gravitation. So Newton's law of gravitation gives the force between two massive bodies, right? So it gives the gravitational force between two massive bodies, right? And he found out, Newton found out from this experiment and using the Kepler's law that if we have two masses, F1 and M2, and remember these are point masses, right? So if we have 2 point masses and we have a separation between them, so force would be directly proportional to the product of the masses, and the force would be inversely proportional to the square of the separation. And when we remove this proportionality constant, so there will be this constant, and this constant was figured out by Cavendish. So Henry Cavendish calculated this value of G, and he found out that G is 6.67 into 10 to the power minus 11 Newton and meter square per kg square, right? So this is called the gravitational constant. And this force is independent of the medium, right? So if we put this system in water, if we put this system in space, if we put this system in anywhere in glass, so they will feel the same gravitational force in everywhere, right? So that is independent of the medium. Okay. So this is called the Newton's law of gravitation, and it gives the gravitational force, and this force is a vector quantity, right? So F is a vector quantity, right? And this gravitational force is the weakest force, weakest known force. So we have generally four forces: strong force, weak force, electromagnetic force, and then this gravitational force. So this gravitational force is the weakest force among all the forces. Okay, and it is applicable to point mass, right? So, but we have studied in the system of particles that there are different. So there are system of particles, right? So for those masses, for the spherical masses, for the symmetrical masses, we will use the idea of the center, right? Okay, so this is the Newton's law of gravitation, and let's say if we have right, so the second topic is superposition principle. So okay, but before we do that, let us write the Newton's law of force in the vector form. Right. So in vector form, what would be the gravitational force? So we have the xy, right? And let's say this is so let's say this is R1 and this is R2, right? And we are calculating the force on one. So this is M1 particle, this is M2 particle, and we want to calculate force on M1 due to this M2, right? So due to this Yeah, so and I have also forgot that this is an attractive force, right? So this mass will try to attract this mass towards its direction, and this mass will apply the force of gravitation towards this direction, right? So this is an attractive force. Okay. Yeah. So let's say we want to calculate force on one due to this two, right? And this is the vector form. So we have to calculate this separation, right? We know that this would be G, M1, M2, and this distance, right? So this distance would be how much? Let's say we want to calculate this one, right? So let's say this is delta R, and this would be how much? R2 minus R1, because we have this vector. Okay, so let me write it this way. So we have this vector, we have this vector, and we have this vector. So using the triangle's law, let's say this is x. So using the triangle's law, R1 plus x, that would be R2. So x is how much? R2 minus of R1. Okay. And let's say I write the magnitude of delta R as R, right? So this would be R square, and direction would be how much? So that would be, let's say, delta R 1, right? So this is 1, so this is R 1 hat. Okay. And if I write it in vector form, so this is G M1 M2 divided by R2 minus R1 and whole cube and R2 minus R. So in this way, I can write it in the vector form. Is this part clear, guys?
Yes, sir.
Yeah. So we know that this is dependent upon the separation square. This is product of the masses, and direction is where? So force on one due to two. So due to two, that will attract this M1. So force is in this direction, right? So unit vector in this direction, and that is R21 hat, right? And R21, we know that that would be unit vector. How do we calculate a unit vector? Do you guys remember? What is the unit vector? How do we calculate the unit vector, guys? If you are given the vector and if you are given the magnitude, so how do we calculate the unit vector? Yes,
Sir, if you are given
if you are
vector
given the
and
vector and its magnitude, so how do you calculate the unit vector? So that is why this vector portion is very important, right? We know that vector is magnitude and direction. So I can calculate this unit vector as vector divided by magnitude, right? So this is what I have done in here. So this R magnitude is magnitude of R2 minus R1, this magnitude, right? And this was, so let me write it here. So this is G M1 M2, and this R is magnitude of R2 minus R1, right? Magnitude of this thing, R2 minus R1, this vector. So magnitude of this square, and this unit vector, it would be how much? That would be vector. This is the vector, right? Divided by its magnitude. So magnitude is how much? This one. So that is why this is a square, this is 1. So this would be M1, M2, R2 minus R1 divided by this magnitude whole cube. So this is the vector form of the Newton's law of gravitation, right? Is this clear, guys?
Yes, sir.
Okay. So now what we will do? Yeah. So let us write this as 1, right? Because yeah. So let us write. We are going from 1 to 2, right? We are going from 1 to 2. So let us write this as 1. Let us write this as 1. But remember that this is R2 minus R. Okay. So then we have this superposition principle. Superposition principle says that if we have, let's say, this mass M, and we have this mass M1, we have this mass M2, we have this mass M3, we have this mass M4, right? So what would be the force of gravitation at this object, right? So let's say this is R1, this is R2, and this is R3, this is R4. So force of gravitation on M, that would be individual vector sum of individual forces. So this is called the superposition principle, right? Force on this test mass due to different masses, that would be the vector sum of. So this says that vector sum of individual mass, individual forces. That is the superposition principle. Okay. And we'll do one question based on that. So yeah. F1 is how much? F1 is G and M and M1 divided by R1 square and R1 hat plus GM2 MM2 divided by R2 square R2 hat plus GMM3 divided by R3 square and R3 hat plus GMM4 divided by R4 square and R4 hat. So this is the superposition principle. All the forces will add vectorially. So the vector sum of the individual forces. Is this part clear, guys?
Yes, sir.
Okay, so you guys please note it down, and when we will do one question, then this would be more clear to everyone. So please note down this part. Remember, we have to recall the vector portions to calculate the forces. Always remember that they will follow the vector sum. Okay.
Yes, sir.
Yeah. So please note it down and let me zoom out this one so guys can. Yeah, whenever you guys want me to scroll down, please. Noted, guys.
Finished, sir.
Yeah, then please note down this part. You just remember that in vector form, this is 1, 2. So this would be 1, 2, right? But this 1, 2 is R2 minus R. So we have to remember this one, right? Whenever you guys have noted it down, please. Noted, guys.
Yes, sir. Finished.
Yes, sir.
Please note down this. This is very important, and we have to just remember that the gravitational force follows the superposition principle, right? So in superposition principle, the total, let me write the statement in here. So superposition principle says that, so it states that the total gravitational force on mass is sum, or to be precise, that is the vector sum of all the individual gravitational force, right? And let's say that this force is 3 Newton, this is 4 Newton, this is 5 Newton, this is 6 Newton. So the total force would not be 3 plus 4 plus 5 plus 6. That would not be the case. we have to figure out the direction as well. So what is the direction? What is the direction? And what is the direction? So this is what the superposition principle says, that this is not the algebraic sum, but the vector sum. Yes, quickly you guys note it down and we will do one question and then we'll move on to the Kepler's laws. So you guys can see from here that these represents the direction, right? So this would be attractive, this would be attractive, this would be attractive, this would be attractive. Noted, guys.
Yes, sir.
Shita and Elham, what about you?
Done, sir.
I'm done, sir.
Then let us do this question, and then that would be more clear. So this is an NCRT problem, and it states that we have so we have 3 point masses kept at the vertices of a triangle, and this triangle is an equilateral triangle, right? So this is mass m. All the masses are equal, right? And the fourth mass that is kept at the center of this equilateral triangle, right? So, and this is 2m. So let's say that this is A, this is A, this is B, and this is and we want to calculate the force at 2m. So what is that? We have to calculate because this is a vector, so we have to calculate the magnitude and we have to calculate the direction. These are two things we have to calculate, right? And this distance is given, which is let's say this is G, centroid. So all these distances are equal, and it is given that this is 1. All these are 1. Okay, so we have to find out F2m. So F2m would be how much? F2m would be, so there would be a force applied by this mass, there would be a force applied by this mass, there would be a force applied by this mass. So there are 3 forces, right?
Yes, sir.
So F2m, that would be how much? That would be vector sum of FA plus FB plus F. So we have to figure out what is FA vector, what is FB vector, and what is FC vector. Okay. So simple thing is that we can calculate the magnitude, right? Magnitude is easy. So let us calculate only the magnitude part. So magnitude is how much? G, M, right? And what is this mass 2m? divided by this distance is 1 square. So this is how much? 4m square g. Is this clear, guys?
Yes, sir.
Similarly, FB magnitude would be same, right? And then the third magnitude, that is also same because distance are same and masses are same, right? This is 4m square.
Sir, how 4m square came?
Oh, 2. Oh, so this is 2m square.
Okay.
Yeah, so this is good, good. Yeah, so this is 2m square. So let us, all these forces are equal. So let us write all these magnitude as F. And we know the value of F, we can put the value later. Clear, guys?
Yes, sir.
Okay, and now you guys will have to remember the resolution of vectors. So that I will ask to each one of you. So we have 3 forces, right? So let's say this total angle is 60. So this would be 30. This is 30, right? And I draw a horizontal line at the centroid of the triangle. So if this is 30, this would be how much? This
30.
is 30. This is also 30, right? And this is some of the force. So I have 3 forces, right? Let me draw the diagram. So I have X and Y. One force is this one. This is FA. Okay, its magnitude is F. I have other force which is this one. This is FC, right? So, and all these are attractive, right? So that is why this is in this direction, this force in this direction, this force in this direction. So I have this force in this direction and this is in this direction. This is 30 and this one is again 30. So magnitude is F, magnitude is F, and this is F. Okay. So now you guys tell me what would be FA vector? What is FA vector?
Sir, FA vector.
Yes. You have some vector which is like this. Let's say this is 5. So what is this vector?
J cap.
So F J cap. Right? Good. Good. Now I want to calculate this FC. So it will have 2 components, right? It will have one component in this direction, other in this direction. So FC will have F cos theta, right, which is F cos 30. And this is F sine 30. Clear, everyone?
Yes, sir.
So what would be FC vector? F cos 30 I hat
Minus K.
minus, this is J, right? Minus J. So minus F sine 30 G. Clear?
Yes, sir.
Now you guys tell me that what would be FB? What would be FB? What
F
is
cos
FB?
theta minus F cos theta I cap.
Yes, absolutely right.
minus F sin theta j cap.
Good. So these are F, B, and C. Clear? Any doubt in this one, guys? Any question?
No, sir.
So now we have to add these three, right? That would be the superposition principles. Let us write that F to M. So that is FA plus FB plus FC. So this is FA is Fj hat. FB is how much? FB is minus of F cos 30 I hat minus of F sin 30 J hat. Similarly, FC is how much? F cos 30 I hat minus of F sin 30 J hat. This is Fj hat minus of F cos 30 I hat. Oh, so Rishita got disconnected. Plus F cos 30 I hat minus F sin 30 J hat. So cos 30 will cancel, right, guys?
Yes, sir.
So we have the resultant force in J direction. This is Fj minus of sine 30 is half. F by 2, right? J hat, and that is F by 2 J hat. Right, guys? So then
Yes, sir.
what would be, so this is how much? Oh, this is 0. F minus F by 2, F by 2 is, this is Fj, and this is Fj. So this is okay. Yeah. It is on this one. This will pull, this will pull right, and this will pull in this direction. Yeah, where did we do? That is F cos 30 and minus F sin. That is correct. That is minus F cos 30 and that is minus F sin. So this should be correct, right? So we will have, yeah, we will have this. So net force would be 0, right? This would be in the equilibrium. So please note down this part, and if you guys have any question, please ask. Yeah, I will zoom out this one. And if you guys have any question, please ask. And let me see the NCRT question because they were getting the different answers. Yes, you guys please note it down, and if you guys have any doubts, please ask.
Yes, sir.
Yes, that is. So, did you guys understand this part?
Yes, sir. So both at the end, FB equals to minus F cos 30I minus sine theta sine 30J, right?
Right, right. Yes. So FB is this one, right? So FB will have a component in this direction and in downward direction. So then this is F cos 30 minus I as Akib said, and then minus F sin 30 minus, right? So, yeah. That is why the vectors are very important, right? Always remember that whenever we are talking about the gravitational force, so that is a vector, right? So that will follow the vector sum of the individual forces. Whenever you guys want me to scroll down, please do it. So you guys saw that F total is 0, right? So this system is in what?
Sorry, sir.
Yeah, so F net at 2F, F net is 0 at 2F, right? So
Yes, sir.
this is at what? This 2F.
0.
So this 2M is at equilibrium, right?
Yes, sir.
Because total force is 0 at that point. So that is that. Whenever you guys want me to scroll down, please do it. Yes, noted. Should I scroll down this one?
Finish, sir.
Yeah. So then
Yes, sir, done.
please add it down this one, right? Yes, completed, guys.
Yes, sir.
Yeah. Then let us talk about this capitals. First is law of orbits, right? So earlier, Copernicus, Galileo, and all those physicists, they say that the Earth. So we have this planetary system, and the Sun is situated at the center, and all these planets are revolving in a circle, right? So okay, so before we do that, so we have this circle, right? And let's say this center is Sun, right? So and let's say this is Earth. So this distance would always be the same, right? Because this is the radius, right, guys? Yes, everyone.
Sorry, sir.
Yeah, so all these distances would be same, right?
Yes, sir.
If this is a circle. But let's say I have this circle and I press it from this. So I have this circle and I press it from above, right? So I have this circle and so I have this circle and I press it from above, right? So it will be in this shape, elliptical shape, right?
Yes, sir.
So this shape, So this shape is called the ellipse, right? You guys have mathematics, right?
Yes, sir.
All of you guys have mathematics. Amna and Ilham, do you guys have mathematics?
No, sir.
Yeah, so whenever now if I have this center, so now I can't have any center, right? Right? Because what is that? Because I have, if I draw a line, right? So this line, this length would be greater than this length, right, guys? Earlier, this length was equal to this length, right? But now this
Yes.
length would be greater than this length. So this is called the major axis, and this is an ellipse, right? This is an ellipse and this is a circle. So this ellipse will have two distances. One would be this major axis, and then we have this minor axis. Okay. So this major axis is denoted by 2a, and yeah, so let's write it as this is 2a, and this half distance is semi-major axis. So this is a. Okay, and this is a. And this is semi-major minor axis. This is b, and this. So these are the okay. And the law of orbits says that the planet will move in the elliptical orbit. So they will not follow the circular orbit, but the planets, let's say Earth, so that will follow this elliptical path. Okay, so that is the law of orbits. So the planets will follow not the circular orbit, but elliptical orbit. And where this sun would be placed at. So there are two focuses of this circle. So this is focus 1 and this is focus 2. So sun is situated at let's say one of the focus. So let's say this is here at the sun. This is the sun at. Okay. So this is our sun. Sun is situated at the focus, one of the focus, and planets are revolving in the elliptical orbits. So that is the law of orbits. Okay. And this point, so there will be 2 points. Let's say this is P and this is A. So what can you say about this P point and what can you say about this A point? What you guys can see? Yes, guys, what can you say about these? So this is the smallest distance between the Earth and the Sun, right? And this A distance is the farthest, longest distance between the Sun and the Earth or the planets. So this is called the perihelion, and this is called the AP. Sorry. Okay. So this point is at the shortest distance, and this point is at the largest or longest. The law of orbit says that the planets planets around the sun revolve in the elliptical orbits where sun is located at one of the foci of the ellipse. Is this part clear, guys? Yes, is this clear?
Yes, sir.
Yes, sir.
Yeah. So this is law of orbits, and then you have this second one is law of area. So law of area says that, let's say you have this elliptical orbit, right? And this is the sun. So let's say this is the sun at one of the foci. This is sun, and this is, let's say, earth. So let's say the earth goes from this point. Earth is rotating and goes from this point to this point, right? And let's say the earth goes from this point to this point, right? So, and both both the area, so there are two areas, right? One is this one, and the other one is this one. So the second law says that the area swept by planets would be equal in same interval of time. So what does it mean? That let's say this time is delta t, right? And this time is also delta t. So whatever this area is, this would be equal to this area. So let's say this is A1 and this is A2. So when the Earth is closer to Sun, so it will move fast this area, and when the Earth is farthest to the Sun, so it will go slowly, right? Then it will cover this area. So this area would be equal to, both the area would be equal in time interval delta t. So this delta t is here. If I have different time interval, then these area could be different. But in equal interval of time, so let's say from here to here, the Earth reaches in delta t time. And from here to here, the Earth reaches in delta t time. So both the time are same, then these areas would be easy. So that is the law of area. And this comes from the conservation of angular. So from the conservation of momentum, what can you guys tell about the speed at this region and speed at this region? So in here, the speed would be faster or slower? Yes, closer.
It will be equal.
No, speed cannot be equal, right? If speed is equal, then it will cover different distances, right? So area would be different. Speed cannot be equal. So you see that it reaches from here to here, right? But in the case of closer than the sun, it reaches from here to here. So it is moving fast, right? So closer to sun, speed will be, speed is faster, right? And farther, the done, the speed is smaller, right? So in here, this will cover this distance, and in here, this will cover this distance. So that is why the area would be equal. Is this part clear, guys?
Yes, sir.
So in here, it will quickly move from this point to this point, and it will in here it will move slowly from this point to this point, right? The time would be same, only the speed will increase. So that is law of areas. And the third one, which is the important one, which says the law of periods. So law of periods says that the time period of or the square of time period of rotation or revolution would be cube of the separation, right? So it says that t square, this would be proportional to the r. That is the whole idea. Okay, these are the three Kepler laws. So any doubt in these laws, guys?
No, sir.
No, sir.
Yeah, then please put down. And in the next class, we will talk about the acceleration of gravity at different positions. In the next class, we'll try to finish this chapter. Whenever you guys have noted it down. Is this visible? This
Yes, sir. I'm done.
done. Okay. And what about you guys?
Finished, sir.
Finished already? Yeah. So this cube of separation, this separation is the major, semi-major axis, right? So that we talked about earlier. So this is t square is proportional to a cube. Semi-major axis is a, right? So this is the semi-major axis. Yeah. So Elham and Amna, what about you guys? Did you also complete this?
Yes, sir.
Okay, so we will stop it here and yeah, so we'll continue from here in the next class. Okay. Bye guys and see you in the next class. Allah Hafiz.
Thank you. Assalamu alaikum.
Welcome. Salam.